We take our laboratory refined sulfur, which we know the value of, and we mix it with a substance called lithium carbonate. We do this for two reasons. We get a very even sample because the lithium carbonate is a binding agent, so there's no lumps and bumps in the sample that the machine's going to look at. We also do this so that we can make samples in 3 different strengths. If we just look at a pure sample, the machine will say, yep, that's a pure sample. So if we split it up into 30%, 60% and pure, then we know that we've got a fairly accurate average to work on. By the way, preparing the samples takes about 2 hours, and if you'd like to know a little bit more of that, I suggest you watch the film. So our samples are ready. The analysis process begins. The machine looks at the 30% sample, gives us a readout and said, yes, I can see approximately 30%. In fact, fairly accurately 30%. It looks at the 60% sample. It says, yep, I can see 60%. It looks at the pure, or as pure as we can get, sample, and it says, yes, I can see a pure sample. So far, we know that the machine is working correctly. It's seeing the proportions because we know what the proportions are, and we are getting the correct readout. We are now going to do the same thing again, but using the real discovery samples, which are the unknown value. So once again, a 30%, a 60% and a pure sample are prepared. That takes us another 2 hours. We subject them to the machine's analysis. It looks at the 30% sample, but something's not right. The reading goes off the scale. It's saying, I'm seeing a lot more than 30%. It looks at the 60% sample, and again, the reading is off the register.
An X-ray fluorescent technician was to supervise an analysis of the Brimstone samples. In order to provide a sample good enough for the precision of the X-ray fluorescent spectrometer to read, Andy had to be very thorough in his preparation. In short, Simon's Brimstone samples were to be analyzed. Then the same tests would be conducted on sulfur flowers that had been chemically refined by laboratory methods. Sulfur flowers are the purest form of the element available today, being over 99% pure. The test results are then compared in order to give a benchmark or standard so that the purity of the Brimstone samples can be ascertained. Beginning by hand, Andy set about crushing one of Simon's samples. Even at this stage, Andy remarked on how pure the samples Simon had provided appeared. Both the standard sulfur and the Brimstone were then mixed with a binding agent, lithium carbonate. Next, it was mixed in a blender and then pressed in a machine to a compression of 40 tons. Having pulverized the samples under 40 tons of pressure, they now have to be removed from their containers. What they are left with is this. 6 samples for analysis have been prepared, 3 of the standard sulfur flowers and 3 of Simon's samples. A bit like slides for a microscope, but much more precise. Andy has achieved 2 things in his preparation. Firstly, he has produced samples that are homogenized, that is to say, of a uniform consistency over the whole surface of the preparation. So the X-ray fluorescence spectrometer will have a very even sample to look at. If only one test is done or only one concentration used, there is a greater chance that mistakes can be made. The amount of the substance they are analyzing shows up in proportions relative to the binding agent or other ingredients in the sample. Each concentration will give a result showing the percentage of the purity of the sulfur and identify the other elements in the sample. If the percentages are about the same, we can trust the results to be accurate.
I'm getting higher results
of the sample.
Yes.
Nothing can be 150% of itself, can it? What was happening was difficult to grasp.
But if you're finding it actually sort of embedded in the walls and things like that.
To cut them out with the walls.
Right. No.
Yeah, my husband spent an hour cutting out
Right.
one out of actual rock where it was just so embedded in the rock because you couldn't actually pull it out.
Right.
I've got a prize specimen at home. It's about the size of my fist.
Right.
And I cut it right out of the rock, and I stood in the rock, left it in there, where it's come down.
Right.
And embedded itself.
Right.
It may have burnt for some time, but then.
Yes. Yeah, because the outside probably would be very hot and therefore it would burn then. Yes. No, I haven't seen anything like that.
The test is abandoned. There's obviously something wrong. 3 new samples are prepared. Takes another 2 hours. You probably have a bunch of scientists ringing their wives saying, we're going to be home late. So once again, the analysis begins. The machine looks at the 30% slide. It says, no, I can see a lot more than that. In fact, it goes off the scale again. It looks at the 60%. It says, no, I can see a lot more than that. So it looks at the 100% and says, yep, I can definitely see 100% or more. We now have the head of a science department who is very confused, trying to explain to himself and to the other people in his department, to Simon and his crew, that nothing can be more than 100% of itself, can it? The X-ray fluorescence spectrometer test is abandoned. A much cruder test is employed, a crucible test. Basically, they set fire to the sulfur, analyze the burning process, and collect data from it. They satisfy themselves that this is 93% or more. Now that's still 13% more than any other natural known form of sulfur. Went as high as to say maybe 96%. I have a question. I may not be a scientist or an analyst, but I do know something about the rules of analysis. If you do 5 tests and get the exact same result, and you do 1 test and you get a different result, you don't accept that test at the expense of those tests. That is not scientific. What you do is you accept the 5 tests that all say the same thing and reject the 1 test that gave you a different outcome. That's scientific. I want to ask some questions here. What do you deduce from the Brimstone analysis? How would you explain the high quality purity levels revealed by these tests? Purer than any other natural form known to man at the moment. What do you deduce from the 5 identical off-the-scale results? Which result would you accept? The 5 or the 1? What do you think about sulfur samples that are found in walls with evidence of high velocity entrance from above, leaving scorch marks showing evidence of immense heat. How would you evaluate the fact that these samples are found in 4 locations in the world in the country of Israel? Those 4 locations are Zeboim, Admah, Gomorrah, and Sodom. The 4 cities of the plain, exactly as it's related in the Bible today. How do you explain that? There is a theory that this activity can be accounted for by volcanic activity. Well, let's have a look at that theory just for a moment, shall we? What do you think the chances are of 4 simultaneous eruptions happening in 4 different locations? Or perhaps even more preposterous, what's the chances of one eruption taking place that then selects 4 locations to drop its debris on, leaving tens of kilometers between the sites? Look at the difference. When we look at the purity, the size and the consistency, the samples from the city of Gomorrah bear little or no resemblance to the volcanic samples that we're more used to seeing around the mouths of volcanoes. Doesn't add up. But the whole theory actually collapses even more so when we discover that there is no volcanic activity that has ever been discovered in these locations, nor anywhere near them.